Hi everyone. Today what we're going to work our way through is a second way to graph lines, basically when we don't make mistakes. Okay, so this becomes a second way for us to be able to work through a very, very efficient way of being able to graph lines. It's called graphing by intercepts, and you can see that title at the top. But to get things started today, I want to go through a quick review then and make sure that we are all good with our previous method to graph. That is graphing by slope intercept. So you take a peek at those two equations that I've put on the screen, and what I want you to do is I want you to go through and I want you to graph those using slope and intercept, just as our previous lesson. I'm going to argue that question A should take you about 20 seconds to get through. Problem B, maybe a little bit longer, let's say 40 seconds. So I think we're working at a pretty good pace. If by the time we transition and everything, we are good to get through those two problems in about a minute and a half. Okay, so I want you to go through, graph both of those, slope, intercept. Okay, pause the video now. Okay, and we should have been pretty good to get through A. We notice that we have our slope of -3, and we have a y-intercept of 2. So I'm going to plot my y-intercept at 2, have a slope of -3, so I am over 1, down 3, over 1, down 3, and so on. I can connect that now. Oops, I just went down 2 on the last one. Down 3, and there we go. Let's connect those. Extend it, the width of your grid. We've got arrows on the ends, and we are good with that graph. Okay, we're getting a little confirmation on B. Unfortunately, the equation in B is not written in slope-intercept form, so I've got a little bit of work to do. I'm going to have to rearrange that equation, which means I need to get rid of the positive 3x. So I'm going to subtract 3x. Now to get rid of a times by 2, I need to divide by 2, and I need to divide everything by 2. So we should get down to that red equation, of which we notice that we have a y-intercept at 3 and a slope of -3/2. So I have a run of 2 and a rise of -3. A run of 2 and a rise of -3. Or I have a run of -2 and a rise of +3. However you want to look at it, get down a couple points, out comes your straight edge, line through everything, extend it the full width of the grid, and we are good. So there should be our two lines. That should give you a quick confirmation as to how well our previous method of graphing went. Okay, we need that to be automatic. Now let's jump into a new method for today. So what you'll see up on the screen is now our new way for being able to graph. So I'm just going to slide that up a little bit to give us lots of room. What graphing by intercepts is it's a method that's used that's based on what is the key and most important information that we need to be able to graph a line. So if I was to ask you, how many points do we need to be able to graph a line? I hope your response to me would be 2. Now, when we did tables of values, we recommended 3 points because sometimes we can make some mistakes. However, this is a method for when you don't make mistakes. So we want to limit it then to 2 points. And sometimes the easiest points to find, most often the easiest points to find, are the intercepts. So what we're going to do is we're going to algebraically find the intercepts, and then what we're going to do is we're going to graph them. So we have a little bit of notation that we need to get down. I would need to see all of this algebra to graph by this method. Okay, so the first thing, we're going to go through and we are going to find a y-intercept. Now, if I was to highlight that y-axis, we're going to find where does our line hit that axis. Then we should all be good about one thing that every single one of those points have in common. that they have an x-coordinate of 0. Notice everywhere along your y-axis, the x-coordinate is 0. So for me to find my y-intercept, then that means that I'm going to sub in x equals 0 into my equation. Now, I never need to see this line, but I'm going to put it down just for this one. Why is finding intercepts a really efficient way to graph? It's because every time I sub in a variable's value as 0, it wipes out that term. We see it there, 3 times 0 is 0. And so if I was to get rid of that equation and look up at my original equation, then when I sub in x equals 0, this term is gone, which means my equation becomes a pretty simplified 2y equals 6, of which now I could solve that by dividing out my 2. I get a y value of 3. What did that just tell me? Well, it told me that on my y-axis, I have a point at 3. So I can plot that point at 3. Okay, I'm just going to get rid of that green arrow. And now what we're going to do is we're going to find our second point. Okay, for a line, I need 2 points. Well, I'm going to find the other intercept. The other axis, the x-axis, has an intercept as well. And if I was to highlight again, well then what's true about every point along the x-axis? Notice that every one of those points would have a y-coordinate that's 0. And so what I can do is do the exact same thing. I can replace my y with 0. I'm going to write this down. Again, you would never need to show me, because we see that when I replace it with 0, it wipes out that term. So if I then eliminated that line from my solution and I looked back up into my equation, subbing in 0 for y wipes that term out, and I come in at a very simplified equation of 3x equals 6. Now I can solve that, divide out my 3. Well, that tells me then that on my x-axis, I have a point at 2. There's our 2 points. We can go ahead now, since we don't make mistakes, we can connect those 2 points, extend it the width of the grid, arrows on the end, and there we go. Now, I just want to draw your attention a little bit. Take a look back up to the first equation, and you'll notice that we have the same graph. I'm going to bet that for some of us, we could actually be faster at graphing using intercepts because the equation was given to us in that different form. Again, we almost call that standard form. That this becomes a really valuable method for being able to graph when the y is not isolated. Okay, let's jump through and let's do one other problem. We're going to tackle B together. Okay, for me to go through and graph my line, I need 2 points. So maybe what I find is maybe this time I find my x-intercept first. So to find my x-intercept, I say what's true about all points on my x-axis? The other coordinate is 0. So by subbing in 0 for y, that wipes out that term. Well, it doesn't really wipe it out. I replace it with my 0. Okay. Now, that gave me a really small simplified equation. To get rid of my times by 4, I divide by 4. And I get an x value of 3/4. That tells me on my x-axis, put a point that's at about 3/4. Now you'll notice that I also put a much smaller point there. Because I'm having to estimate where that is, I really want to be as exact as I can be. Okay, now I have to find my y-intercept. Well, to find my y-intercept means my x value equals 0. This is what's nice. That wipes out that term. Well, you actually knew that your y-intercept was -3 anyway, because you can identify your y-intercept when the equation's written in the form y equals. Okay, that tells me then that on my y-axis I have a point at -3. I now don't make mistakes. I can connect those 2 points. Ooh, that was not a good connection. That's better. Extend it to width, put arrows on the end, and we are good. Okay, there we go. So all we're going to do today is we're going to work our way through maybe some of the quirks, some kinks that we might run into as we start to graph by intercepts. Okay, so let's take a look at C then. I think that quite a few of us are ready to start tackling this stuff on our own. So what I want you to do is I want you to write down right below your grid all of your algebraic work that you need to display. And I want you to go through and I want you to graph the equation given in C. Okay, pause the video now. Okay, we're back. So if I'm going to work my way through, then maybe I find my x-intercept. That is really messy. I'm going to clean that up. And I know that to find my x-intercept, then that means that my y value equals 0. So that's going to give me 3x equals 8, and I can solve that pretty quickly and get my 8/3. Now, I made a comment in class earlier about maybe the use of mixed numbers. And one of the really valuable ways to use mixed numbers is when we have to graph values. That to change this to 2 2/3 might be really useful for us. Because rather than saying, okay, well, where is 8/3 on our number line? We could now go to our x-axis and go to 1, 2, and about 2/3 of the way to the next value. So I'm just going to get rid of all those little arrows. But what that does allow me to do then is to say that I roughly have a point there. Okay, now I can go through and I can find my y-intercept and replace my x value with 0. And some of us just made our key mistake. I want you to be very careful if you wrote this down on your page. If we did, we made an error. Take a look back up at our original equation. So I'm just going to kind of draw your attention up here. Take a look back up. If I sub in x equals 0, that's going to wipe out that term. That doesn't change the fact that my y term is negative. So now that equation is correct, that -2y equals 8, and therefore y equals -4. Plot your point at a y value of -4, and now we can go through, use our straight edge. My straight edge doesn't always look so straight on the iPad. Yours will look so much better. And there we go. Okay, hopefully that matches up and we start to feel a little more confident with being able to go through and graph by intercepts. Okay, same thing as we get to D now. I'd like you to go through, do all that algebraic work down below, and produce a picture for D. Okay, pause the video now. Okay, and we're back. So I should be able to pick up the pace a little bit. We found our x-intercept maybe, so we know that our other coordinate's 0. That's going to end up giving me 4x equals 6. And when we divided that out, we also reduced that fraction to 3/2. So on my x-axis, I can go to 1 1/2. There's my 3/2. On my y-intercepts, then that means that my x value is 0. That's going to get me 3y equals 6, and so y equals 2. That's a nice, easy one to plot. And now when I go through to connect, I'm trying to be as accurate as I can be. That one might have been the best line I've drawn on here. And there we go. Okay, so hopefully we have a little confirmation, and hopefully this new method is pretty quick for us to be able to produce a picture. Okay, let's jump on down to the last two. Okay, I would like you to take a look at E and F. Now, I'm not walking through E and F for the purposes of us going through and graphing by intercepts. So we're going to kind of skip some of that a little bit at the beginning, because everybody should be able to recognize that when I have a line that says y equals 4, that tells me that my y coordinate is always 4. So on my graph, that horizontal line represents my y coordinate equaling 4. I'm done. Like, there's your line. Now, I'm going to actually draw on a line rather than highlight that value, but we should be good with that. And that should take us like 5 seconds, 10 seconds. Take a look at F. The same thing in F. Question F says, okay, well now my x value is -2. So if I highlight all the x values, or the points, sorry, all the points, I really didn't like that highlight, all the points that have an x value of -2, then I'm going to get something like that. And we know that when we see an equation that is x equals a constant, that's a vertical line. What I want to do when I walk through E and F is I want us to see the way that shows itself as we work to find intercepts. Okay, the way it shows itself. So I'm going to walk through E as if I didn't know the purple was the case. Okay, so maybe I go to find my y-intercept first. So that means make your x value 0. Well, in my equation, there is no x. So my y equals 4. And so on my y-axis, I plot a point at 4. Okay, that's not that unusual. A little unusual, but not that unusual. Now I'm going to find my x-intercept. So to find my x-intercept means that I allow y to equal 0. And that gives me this equation, that 0 equals 4. Okay, the first thing to notice, is there a variable in there? No. So that statement is telling me that 0 equals 4. When does 0 equal 4? And your answer to that question should be never. 0 doesn't equal 4. And so really what that becomes then is the statement that there is no solution. So what that means then is there is no solution to finding an x-intercept. And therefore, there is no x-intercept. So if I was to ask you to draw a line that goes through a y-intercept at 4 that has no x-intercept, will never cross the x-axis, then I'm hoping that we can look at that and we can say, well, then our line has to be parallel with the x-axis. The only time that my line will never hit the x-axis is if it's parallel to it. So I need to draw a line that goes through that red point that will never cross the x-axis. That means it has to be a horizontal line. And so we come in on what we already knew. We already knew that y equals a constant gave us a horizontal line. We can just see that now in how it shows itself when finding intercepts. Okay, I want you to try the other. Like, give F a shot, just to work through the algebra to see if we confirm that we would get that purple line. Okay, pause the video now. Okay, we're back. So if I was to work my way through, I'm going to find the y-intercept, which means I allow x to equal 0. I now get 0 equals -2. And how do I feel about that? I feel that there is no solution to that equation. And if there's no solution to that equation, then that means that I have no y-intercept. So I need to draw a line that has no y-intercept. That means it has to be vertical. Okay, I'm drawing a vertical line. Now what I need to find is my x-intercept. And I do that by making y equal to 0. Well, there is no place to sub in y, and so x equals -2. And so if I plot that point at x equals -2, now what I have to do is just put those pieces of information together. I need a line that goes through x equals -2 that never crosses the y-intercept. And so if I just get rid of that shaded in portion and we jump back to our line, then the only way I can do that would be to draw a vertical line through -2 as an x value, arrows on the end, and we get a little confirmation. Okay, there we go. So the key focus for us is, can we graph in like questions 2A through D a line by using intercepts? We saw how it shows up as we work our way through E and F. Okay, same thing as always. Job now is to be able to go through and be able to graph using this method very quickly. You will be responsible on an evaluation for graphing using both of these methods. So we need to get a bunch of practice at getting good at it. Okay, good luck.